Alright guys, we are going to be looking today at finding domain and range for functions and relations. Both functions and relations have domain and range. So we're going to go ahead and jump right in. The student will be able to determine domain and range of functions and relations graphically and algebraically. So finding domain and range. Domain is the set of all x values contained in the function or relation. Range is the set of all y values contained in the function or relation. Now, domain and range tend to, for some reason, give some people some headaches. I just want to go through some simple tips and tricks with you. Like I said, domain is the x value. Range is the y value. So let's look at our graphs here. If we're trying to find the domain and range from a graph, just pick one and go with it. We're going to start with domain. Domain is the x values. Okay, if you notice, x is that axis. Okay, so it's how wide your actual graph is. So my graph is this curve. I'm trying to figure out how wide the graph goes. Okay, so what you want to do is look at the widest part of your graph. Okay, wide. So from left to right, where's the biggest piece? Okay, so the farthest out to the left is that arrow. The farthest out to the right is that arrow. Now what you want to do is ask yourself, where are those arrows going? Okay, so we're going to start with the left one. Obviously, the arrow is going to the left. When we're talking about right and left, we're talking about the x-axis. On the left side of the x-axis, this is negative infinity. On the right side, it's positive infinity. So if our arrow is going to the left, I know that it's going towards negative infinity. I also notice that my arrow's pointing upward. Up and down deal with the y-axis, and that means up is going towards positive infinity, down is going towards negative infinity. So since my arrow, this arrow right here, is also going up, that means it's going towards positive infinity. Okay. So same thing on the other side. This arrow, it's going to the right. The right side of the x-axis is positive, so it's going towards positive infinity. Then, the arrow is also going up. Okay, up means it's going towards positive infinity. So if I'm looking for my domain deals with the x values. So I look at the widest part of my graph, which is the arrows that I just talked about, and I look at the x values. Here's the first one. Here's the second one. Okay. So our domain goes from negative infinity to positive infinity. All right. So we're done with domain. Now let's talk about range. Change the color. Range deals with the y values. Okay, y values. Talks about how tall your graph is. Okay, I know the tallest part of my graph is again the arrows. That's the tallest part. The lowest part is going to be down here at the vertex. Okay, so where the U shape, where the lowest part of the U is. All right. Now, obviously here I don't have a point. I don't have a coordinate. Let's just say for all intents and purposes that my coordinate was 1 and negative 2. Okay. So if I'm looking at my range, I'm looking at the tallest part, which is the arrows. Both of the arrows have a y value of positive infinity. So for my range, the biggest number always goes last. The biggest number comes from the tallest part, and we just underlined both of those pieces. It's infinity. The first number comes from the lowest part of your graph. The lowest part, we just said it was the vertex, the bottom of the U. Its y value is negative 2. So negative 2 is our first number. That's how you determine domain and range. Let's look at this next example here. Okay. Again, we're starting with domain. It deals with the x values. of the widest parts of our graph. The widest part of my graph, these arrows. Now again, our job is to figure out the coordinates for those arrows. Remember that for x, our x-axis goes from negative infinity on the, I don't know why I'm putting parentheses, on the left to positive infinity on the right. And our y value, our y-axis, goes from positive infinity up top to negative infinity at the bottom. So we're just looking for the coordinate of this arrow to start. Okay, so this arrow, it's going to the left. I know left and right deal with the x value. So the x value that goes to the left is going towards negative infinity. It also kind of looks like it's going up. Up means we're going with our y value. Up is positive, so positive y value means we're going towards a positive infinity. This arrow down here now, it's going to the right. To the right of our x-axis is positive infinity. It's also going down, which means our y value is going to be negative infinity. So these are the coordinate points for my widest pieces of the graph. Domain, again, domain is the x values. Okay, so our domain is going to go from here, negative infinity, to here, positive infinity. Our range, it's our y value. It goes from the tallest, or let's start with the shortest, so negative infinity, because that's the lowest piece on our graph, to the tallest, just positive infinity. And that's our domain and range. Domain and range from a chart or table. From a chart and table or a set of ordered pairs over here, it's very simple. You just look at your list and you write it out as a set. So here we have our x values. This is our domain. And our y values, it's our range. Okay. You don't get away with it that easy, though. You do have to write it as a set. So domain is the set of values that include 1, 2, 3, and 4. The range is the set of values that go from 6, 7, 8 to 9. Okay, and that's our domain and range. Ordered pairs, same deal. Remember, an ordered pair is always written as x comma y, so the first number is always going to be our x values, so these are all of our x values, so they will be our domains, and we're going to put them in order. So our domain starts at -8, we have a -1, 2, 3, and 100, that's our domain. And then our range, it's going to be our y values. So all of these little y values. Again, we're going to try and put them in order. So we have -74. And then I have 4, 7, 8, -74, 4, 7, 8, 9. I'm losing my mind for a second. All right, that's our domain and range for the set of ordered pairs. Finding domain and range algebraically is where it might seem to get a little tricky. From here, all we're going to do is we'll start with our domain, right, one thing at a time. So if I'm trying to find the domain of this first equation, what I need to do is solve this equation for y. I want to get y by itself. So I'm just going to subtract 7x from both sides. And I have y equals negative 7x plus 5. So if I look at this, I have to look at my x values and how it affects everything. Because I'm multiplying x by negative 7 and adding it to 5, as long as I plug in some number, some real number for x, I will always get something out for y. Like if I plugged in, I'll just give you an example here. If I plugged in 0, right? If I plugged in a 0, I'd have negative 7 times 0. That's 0 plus 5 is 5. If I plugged in 100, right? 100 times negative 7 is negative 700. Plus 5 is negative 695. If I plugged in, I don't know, negative 100, negative 100 times negative 7 is positive 700, plus 5 is positive 705. So it doesn't matter what I plug in for x, I will always get something back out for y. So my domain can be any number, meaning my domain goes from negative infinity, it's not a fancy bracket, it's just a parenthesis, to positive infinity. Okay, that's because the domain here is all real numbers. So let's talk about range. The range, because x can be any real number and you still get a y value out, that means that y can also be any real number. So meaning I could plug in any value for y and I would get an x value back out. This means that our range is also, I don't know why I keep drawing fancy brackets, parenthesis, from negative infinity to positive infinity. It's also the set of all real numbers. Okay. In example 2, I have y equals 3 divided by x minus 2. What I have to worry about here is the denominator. Okay. My denominator, x minus 2. I cannot have my denominator equal 0. Because if it equals 0, like for example, if I had 3 divided by 0, it's going to be undefined. You can't divide anything by 0. If you type that in your calculator, you're going to get an error because it's just not possible. You cannot divide by 0. So since x plus 2 cannot equal 0, I know that x cannot equal 2. So that means my domain can be anything except for 2. So I have to write that accordingly. That means my domain goes from negative infinity to 2, but I'm not including 2, so I'm going to end it in a parenthesis. And I also have to go from 2 to positive infinity. U means union or and. Okay, it's just a symbol that means and. So my domain is from negative infinity to 2, but I'm not including it. If I was including it, I would put a solid bracket there, but I'm not. So I'm just leaving it as a parenthesis. Oops. And then it includes, again, not 2, but any number other than 2 going up to positive infinity. To find the range, the range is going to be from negative infinity to 0, and or union 0 to positive infinity. Here y cannot be 0 because the fraction has a numerator of 3 and it can't be 0. So y cannot equal 0 in this case. So we have our range is negative infinity to 0, also union 0 to positive infinity. If y equals 0, and I went to try and solve for x, I would have to multiply both sides by x minus 2 to get rid of the fraction. So these would cancel out. But right here, 0 times x minus 2 is 0. So I would have 0 equals 3, and 0 does not equal 3. This would be a no solution. That's why 0 is not included in here. So our y value cannot equal 0. That's why our range is what it is. Okay, just a little bit of explanation there. Lastly, I have y equals the square root of x. So when you're looking at something like this where there's that square root symbol, what you're concerned about is what's underneath here. Okay, so we have x. Okay, there's a rule that whatever you're taking the square root of, it cannot be a negative number. Okay, so in this case, x can't be negative. So for our domain, since it can't be negative, it's anything that is from 0 and beyond, okay? And I can take the square root of 0. It is 0, so I'm going to include 0 in that. My domain is going to start at 0 and go to positive infinity. My range, let's think about it. If I have a y value that's negative, does that work? Can I have a negative y value? Well, think about it. If I took the square root of negative, or not, pardon me, y value. If I said negative 4 was equal to the square root of something, if my y value was negative 4, could I have a square root of something? Well, to figure that out, I would have to square both sides, and I would find that x equals 16. So in this case, y can be a negative number because the square root of 16 is 4, and the square root of 16 is also negative 4. So in this case, any number will work. Our range then will be from negative infinity to positive infinity.